Hi, I am Indu Agarwal. The topic which I am taking is matrix algebra. Matrix algebra first appeared in ancient China. The first known example of the use of matrix methods to solve simultaneous equations is given in an important Chinese text, 9 chapters of the mathematical art between 300 BC and AD 200. In its 7th chapter, Too Much Not Enough, the concept of determinant appears. This is nearly 2 millennia before its supposed invention by the Japanese mathematician Sekikowa in 1683 or his German contemporary Gottfried Leibniz. In its 8th chapter, Methods of Rectangular Arrays, simultaneous equations were solved using a counting board that is mathematically identical to the modern matrix method of solution. The term matrix for such arrangements was introduced in 1850 by James Joseph Sylvester. He had a brief career at the University of Virginia, which came to an abrupt end after an enraged Sylvester hit a newspaper reading student with a sword stick and fled the country thinking that the student is killed. Female mathematician Olga Toski-Todd used matrices to analyze vibrations on airplanes during the World War II and became the torchbearer for matrix theory. Now let us define matrix. Matrix is a rectangular array of mn numbers. It is represented by A equal to Aij m into n, that is, matrix A has m rows and n columns. Aij is an element of any ith row and jth column. So, how many types of matrices are there? So, let us see this. Row matrix, that is A equal to A11, A12 and up to A1n. Second, column matrix, which is represented in the column, that is A11, A21, A31 until AM1. Null matrix. This is a rectangular matrix or a square matrix having all elements 0. Fourth, horizontal matrix. In this, number of rows are less than the number of columns. Vertical matrix. Number of rows are greater than the number of columns. Sixth, square matrix. In this, number of rows again are equal to number of columns. Seventh, diagonal matrix. In this, all elements except the diagonal is 0. It is denoted by D1, D2, D3 up to Dn. Eighth, unit or identity matrix. It is a diagonal matrix in which diagonal elements are unity and all elements are 0. That is, Aij is equal to 1 for all i's equal to j and Aij is equal to 0 for all I not equal to j. Ninth, scalar matrix. It is a diagonal matrix in which all diagonal elements are equal, that is A equal to Ki. Now, let us understand the algebra of matrix. Equality of matrix. Two matrices are equal if both have same order and the elements in the corresponding positions are equal. For example, if A is equal to Aij and B is equal to Bij, then A11, A12, A21, A22 is equal to B11, B12, B21, B22. Since both are of order 2, we can say that A11 is equal to B11, A12 is equal to B12, B21 is equal to A21 and A22 is equal to B22. This implies Aij is equal to Bij. Addition and subtraction of matrices. Matrices should be of same order to add or subtract. For example, if A is equal to Aij and B is equal to Bij, then A plus minus B is equal to Aij plus minus Bij, that is A11, A12, A13, A21, A22, A23, A31, A32, A33 plus minus B11, B12, B13, B21, B22, B23, B31, B32, B33 is equal to A11 plus minus B11, A12 plus minus B12, A13 plus minus B13, A21 plus minus B21, A22 plus minus B22, A23 plus minus B23, A31 plus minus B31, A32 plus minus B32, A33 plus minus B33. Now we learn how to multiply the two matrices. A into B is possible if number of columns in A is equal to number of rows in B. For example, if A is equal to Aij m into n and B is equal to Bjk n into P, then A into B is equal to Cik m into P, where Cik is equal to summation of Aij into Bjk, where j is equal to 1 to n. Suppose A is of order 3 into 2 and B is of order 2 into 2, then A into B is A11, A12, A21, A22, A31, A32 into B11, B12, B21, B22, which gives us A11, B11 plus A12, B21, A11, B12 plus A12, B22, A21, B11 plus A22, B21, and we can continue like this. Here AB is of order 3 into 2. Now we will take another example, ABCD whole square, which will give us A square plus BC, A plus D into B, A plus D into C, D square plus BC. Now the transpose of a matrix. In this we interchange rows and columns. For example, let A is equal to Aij m into n, then transpose of A is represented by A to the power t or A dash. So we can write A to the power t or A dash is equal to Aj n into m. For example, if A is equal to ABC DEF, then transpose of A to the power t is equal to ABC DEF. Symmetric and skew symmetric matrix. A square matrix A is symmetric if Aij is equal to Aji, that is, A is equal to transpose of A, which is again represented by A to the power t. It is a skew matrix if Aij is equal to minus Aji, that is, A is equal to minus A to the power t. Adjoint of matrix. If A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3, then adjoint of A is represented by capital A1, capital A2, capital A3, capital B1, B2, B3, C1, C2, C3 all in capital letters, where AI is equal to minus 1 to the power row plus column into minor. Now, what is this minor? Minor of A1 and C3 are B2, C2, B3, C3 and A1, B1, A2, B2 respectively. So, if A is equal to AB, CD, then adjoint of A is equal to D minus B minus C A. Now, what do we mean by inverse of matrix? A inverse is equal to adjoint of A divided by the determinant A. Now, how to solve linear equations with the help of matrix? Let us take the three equations A1x plus B1y plus C1z is equal to D1. A1x plus B1y plus C1z is equal to D1. A2x plus B2y plus C2z is equal to D2. A3x plus B3y plus C3z is equal to D3. I can represent the matrix A as A1, B1, C1, A2, B2, C2, A3, B3, C3. Matrix X can be represented as X, Y, Z. And we can say that AX is equal to D, where D is equal to D1, D2, D3. Therefore, X is equal to A inverse D, and we all know how to calculate inverse of the matrix, and so we can calculate X. System is consistent and will have unique solution if determinant A is not equal to 0. System will be inconsistent and no solution if determinant A is equal to 0 and adjoint of A into D is not equal to 0. We cannot say anything about the solution or about the system if determinant A is equal to 0 and adjoint A into D is equal to 0. The usage of matrices today not only confined for solving simultaneous linear equations, for example 2x plus 3y equal to 5, 5x minus 4y equal to 1, but also for describing the quantum mechanics of the atomic structure, designing computer game graphics and even plotting complicated dance steps. Isn't it wonderful to know? Hope you would have been familiar with matrices by now. See you soon with next topic.